talking about current. Yeah, it's the smell of that ozone that was being created. That or the fire from the, yeah. Yeah, I'm not turning it back on. You can move back up if you'd like. All right, so current. The first property of current that we're going to talk about, define, clear up is potential or electric potential or voltage. Electric potential, which is voltage. Now, we talked a little bit about electric potential last chapter, in that it's the amount of energy that each coulomb of charge carries. So the amount of energy per coulomb of charge. And we kind of talked about this in relationship to gravity. And we brought the example back of the roller coaster and putting the roller coaster up here and saying that it had some gravitational potential energy, mgh. And down here, most of that energy is going to be converted into what? Kinetic, okay, into kinetic energy, but we could say that if it's above the ground, it's got some gravitational potential energy yet as well, right? I'm just going to write that as mgh2. Now, if we're talking about gravitational potential energy, kinetic energy, what variable did we find basically never mattered? Mass. Because no matter how much mass we had in there, the velocity wasn't going to change. So we canceled out mass. GH, and really the difference between these two heights, is what we could call gravitational potential. So it's basically the amount of energy per kilogram that an object would have as it goes from between these two locations. Well, electric potential is the same idea. It's determined based on the electric field that's created and the distance between those 2 points in that electric field. We could also consider it to be the amount of punch that a set of charges is carrying, but really it's the amount of energy that each individual charge is carrying with it. The punch a set of charges. Okay. Obviously, voltage is measured in volts. Measured in volts. And a volt is a joule per coulomb. Okay. Next one, current. Current is the flow of electrons, simply stated. It's the amount of charge that passes through an area in a given amount of time. So the amount of charge that passes through an area in an amount of time. Units for that would be amperes or amps, and that would be the equivalent of a coulomb per second. Megan, go ahead. Yeah. Well, we could talk about one charge. Yeah. If you want to, so let's see here. The amount of energy per coulomb of charge, the amount of punch that, if you wanted to say the amount of punch that a single charge carries, you could. It's just that typically if we're talking about a single charge, meaning one electron, you really don't notice anything unless we're talking about a very atomic scale. Does that make sense? Why does the electric potential change? So based on where other charges are, what electric forces something's experiencing, in the same way that like objects in gravity, when we give them height so that they can fall, when we move electric charges apart, they gain electric potential energy so that they can start moving. Or if we put a pair of like charges close to each other, they gain electric potential energy so they can start pushing apart. Is that the question you're asking? Okay. All right. Current. So amperes, coulombs per second. Couple of details about current that we should have. Currents over zero point 0.1 amps are deadly. 0.1 amps are deadly. Anybody remember what the current of the taser was? 0.03. So way less than this value. Okay. It's not in the, oh, this is just a mild tingling sensation. It's definitely in the ow range, but it's way less than the deadly range. Okay. Typically, your household circuit is set to max out at about 15 amps. Household circuits max out at 15 amps. Any higher than 15 amps and wires in your house would likely start to melt and set fire to insulation. Okay. To prevent this, we use things called circuit breakers and fuses. Circuit breakers and fuses both serve the same purpose, and that's to interrupt a circuit where the current has gotten too high. So circuit breakers and fuses serve the same purpose and may limit current. They do this both based on the same principle, and that's heat. When a circuit breaker or a fuse reaches a certain current, the metal that they're using reacts to the amount of heat that it's experiencing. In the case of a fuse, it melts. And when it melts, it disrupts the circuit, opening the circuit so current's no longer allowed to flow. So a fuse melts, disrupting the circuit. A circuit breaker expands with the heat. And when it expands, it effectively throws a switch, which then does the same thing, opens the circuit. To throw a switch. Circuit breakers are in general more expensive to install. However, they don't need to be replaced every time you get your current too high. A fuse is a one-time use. Every time a fuse melts, it has to be thrown out and replaced with a brand new one. So typically, fuses are used in either older construction houses or in circuits where they don't think that your current is going to be excessive frequently. So things like your car. Your car uses a whole bunch of fuses because you're not plugging in and unplugging all sorts of things into your car very frequently. You're not going to have like the circuit for the headlights suddenly change. So they use fuses in those cases. However, how many of you have ever caused the circuit breaker that's related to your bathroom to pop? Because maybe you plugged in a hair dryer, a curling iron, and something else. Or maybe you've caused the one in your living room to pop because you plugged in 3 Xboxes, 4 TVs, and a stereo. Anybody? LAN party. You guys know what I'm talking
Yeah,
about, right?
I got it.
Okay, cool.
If you've never had your friends come to a Minecraft LAN party, then
I
you're
mean,
not real.
LAN party. All right, so everybody's popped a circuit breaker at some point, or maybe your siblings popped a circuit breaker at some point. You probably all know where they are in your house or apartment or wherever you live. And they're just a switch that goes back and forth. Questions on any of these ideas up to here? Oh, so circuit breakers expand due to heat. They also cool pretty rapidly. So you really just flip the switch back, and as long as that metal has reduced in heat enough, it's just flipping the switch and it goes right back to its original stage. Typically, in order to prevent it from just automatically repopping, you have to turn something off, unplug something, so that you're not trying to immediately draw the same amount of current. Good? Okay. All right. Last idea here, resistance. First of all, it is not futile. Somebody got it. No. As long as you get it, that's all I'm aiming for. All right. Resistance is the impediment of the flow of current. So anything that basically uses the energy that charges are carrying is a form of resistor. So some of that resistance could be in the form of heat. So like we want to talk about a space heater. A space heater is a resistor because it's taking that electric potential energy, turning it into thermal energy. Toaster, very good example of a resistor. Your computer, a lot more complex, but effectively a resistor because you're taking that electric potential energy and you're turning it into something else. This is any device that converts electric potential energy into other energy. Typically, resistance is measured in ohms. Which uses the Greek symbol omega for the units. That's capital omega. Lowercase omega was the W.